Hi there, everybody. Thanks for checking in on this Smoky Tuesday. I'm going to run down some of the test topics once again for you on a video here for our Chapter 10 and 11 test tomorrow. From Chapter 11, to handle that first, that's chiefly concerned with finding the volumes of different things. And so you will have to find the volume of a hexagonal prism, of a triangular pyramid, the volume of a cone and a sphere and a cube. Okay, so those objects are all going to show up on the test tomorrow. The other part of Chapter 11 was this idea about the ratios of similar objects, and I kind of abbreviate that idea with this r to r squared to r cubed idea. This idea of a linear scale factor, the ratio of two lengths on similar objects being one number. If you took that number and squared it, that's the ratio of the areas, of corresponding areas, and we'll do a problem like this in a minute. And if you took that same number, that linear scale factor, and cubed it, that is the ratio of the volumes between two similar objects. We're going to do a problem like this in a few minutes. But before I do that, let's just kind of run down the ideas about circles. So the Chapter 10 was all about circles, and there was quite a few things covered in circles, a lot of vocabulary. I'm not going to have specific vocabulary questions so much on the test, but we'll be using vocabulary, so you do need to know it. One of the biggest ideas in circles that we've studied is this idea of the inscribed angle theorem. And that whole idea of an arc measure being twice the amount of the inscribed angle that intercepts that arc, and that the central angle that intercepts that arc is the same measure. So this 2-to-1 ratio between inscribed angles and arc measure and central angle, that whole trio of objects in a circle, measurements I should say, in a circle, their relationship is part of this inscribed angle, and it shows up in a lot of different ways. So we've been doing a lot of problems like that. There's one special case of that, before I get to the other thing, about an inscribed angle in a diameter, or that is in a semicircle. All right, if you have an inscribed angle who is intercepting a diameter of a circle, that angle is 90 degrees. That's not a different thing. That's just sort of a special, very important case of the inscribed angle theorem. Okay. Another thing that we studied was this idea of intersecting chords and the products of their chord segments. So when two chords intersect, the most dependable and easiest way to figure out the length of one missing part or of some algebraic expression here is to just set up the product of the two parts of the same chord, that equating to the product of the parts of the other chord. So A and B, multiply those together, and that equals C times D. And so if one of them is missing, or if there's a little algebraic expression involved, this kind of equation right here will be the best way to figure that out. Okay, so basically this circles stuff, you'll be finding out arc measures and chord lengths and central angles and inscribed angles, all using these different properties of circles. And there were other properties that were studied in the chapter, but these are the main ones that are going to be used on this particular test. Okay? So to get back to this r squared, r cubed idea, I thought I might set up a problem for you and see what you do. It's very similar to one we did in class. So if you were there in class today, this is just kind of another example, same kind of a thing. It's very similar to a problem that showed up in the book, by the way. So let's say we've got a smaller triangular-based prism, all right? And what I know about that prism is that the area of one of the bases is 14 square inches, and the height of that prism is 4 inches. So there's another prism that is proportionally similar, all right, to it. And the only thing I know about this prism, however, is the volume is 324.8 cubic inches. So I don't know the volume of this one, but I know the height and the area of the base. And the bigger one, though, I only know the volume, and I don't know the area of the base and the height. So to do this ratio idea, I need to find a matching pair of measurements, either area to area, height to height, or volume to volume. Well, I can't really figure these out, but I can figure out the volume of the smaller one. So the volume of the smaller one is going to be 4 times 14, and so that 4 times 14 equals 56, and that is the volume of the smaller prism. So if you know what to do to find out the height and the area from here, go ahead and hit the pause button on the video and try that problem on your own, and then come back when you're done and see how it worked out. All right, did you do that? Okay, well, we're going to continue now. I'm going to assume that you've already stopped the video, done some little bit of work, and are coming back now to check and see how it worked out. So we have a matching pair of measurements in the volumes. So what I want to do is find the ratio of those two volumes. I don't know why I said 5. It's 324.8 for the volume of the larger one divided by 56. And when I do that on Mr. Calculator, it looks like this: 324.8 divided by 56, and I get a number 5.8. All right, so 5.8 is the ratio of the volumes. 5.8 is equal to the linear ratio cubed. That's r cubed. That is the ratio of the volumes, r cubed. So this is r cubed. All right, it's the linear scale factor cubed. So now to find the linear scale factor, that is the ratio of the heights, all I got to do is take the cube root of that. All right, so I'm going to take the cube root of that number. Let's see, I want to take cube root. So I'm going to take that number and raise it to the 1/3 power, because I don't really have a cube root button on this little calculator here. So what is it? 5.8. I'm going to take 5.8. I'm going to raise that to the power of 1/3, and that's the same thing as taking the cube root. And so the number I get from doing that is 1.797. Let's round off to that. 1.797, that is r. So the cube root of 5.8 is approximately 1.797, and that equals our linear scale factor. So to find the height then, all I got to do is take my height over here on this one and multiply it by this scale factor. So 4 is the height of the other one times 1.797. That's going to give me the height of the larger one. So let's just do that here on Mr. Calculator. 4 times 1.797, and that gives me 7.188. That's the height of the larger prism. All right, 7.188. Okay, there we go. So hopefully you got that answer. That's inches as the height of the larger prism. Now, if I want to find the area of the larger prism, I'm going to use the r squared ratio. That's the ratio of their areas. I do have the ratio of the smaller one, so all I have to do is multiply 14 times r squared to get the area of the larger one, okay? So let's do that. 14 times 1.797 squared, that's going to equal the area of that larger base there on that. So let's do that. 14 times 1.797 squared gives me, here we go, I got that number right there, 45.2, let's round up, 45.21. And that's what I got for the area, 45.21 square inches. That's the area of this base here using the linear factor squared. All right, so that's how you use that. I hope that was a good enough quick example. Hope this video wasn't too long. Good luck. I hope everything works out for everybody in their homes today with all that fire business going on. All right, thank you. Bye-bye.